Good morning, students. Okay. Every day we are doing one lesson, isn't it? Okay. I am completing my portion, but you also should study each and every day, at least complete one lessons. Then only it will be easy to you. Okay. Right. Carboxylic acid, you know that before that aldehydes, ketones, carboxylic acid, one lesson, very important lesson. So you concentrate only first of all name your reactions. Name your reaction, some important reaction, some trend. This and all if you go through means you can easily get marks in this lesson. Okay, at compulsory in a very somewhat big lessons. So they'll ask at least 2 questions from this lesson. Okay, right. So 3 topics are there: aldehydes, ketones, carboxylic acid. So all these compounds preparation, properties, and all we are going to study here. Okay. First of all, I'm going to compare. I'm going to combine aldehydes and ketones together. Then carboxylic acid I'm going to take separately. Okay. Okay. So you know that aldehydes means what's the formula? First of all aldehydes. What's the formula for that? RCHO. Ketone means what's the formula? RC double bond O R dash. Okay. All are carbonyl compounds because C double bond O is there. That's why it's called carbonyl compounds. First of all, you should know this is outright. If you want to write like this means okay. What's the hybridization of this carbon? What's the hybridization of this carbon? Around the summary sigma bond 1, 2, pi bond no. Okay. So this is called what kind of hybridization? sp2. 3 sigma bond, yeah. 3 sigma bonds sp2. Understood? 4 sigma bond only sp3. Understood? Okay. Then as usual, we will study some IP's nomenclature. Instead of R, I put CH3CHO, RHCHO, CH3CH2, CHO. Understood? Okay. Or we can put aromatic. Aldehydes means it ends with what? Aldehydes ends with what? Al. Understood? So what? 2 carbon no. So what? Ethanol. 3 carbon no. What? Propanol. You know that. This is all. Benzene plus aldehyde. This one is somewhat different one. Suppose here we can say this is called phenyl group. Phenyl group. Then only 1 carbon no. So what? Methanol. Okay, so phenyl methanol we can say. Ours we have carbaldehyde name is also there. Carbaldehyde name means benzene carbaldehyde. We have common name, IPSC name, carbaldehyde name. Okay, common name is called benzaldehyde. IPSC name is called phenyl methanol. Okay, carbaldehyde name is called benzene carbaldehyde. Suppose for example if you are like this, CHO, how will you say this name? In this case only we should use carbaldehyde name. Carbaldehyde name means here this is called benzene. 1 and 2 having carbaldehyde group is present. So what? Benzene 1, 2 dicarbaldehyde. Understood? Right. So understood. You go through all the names. This is given in your textbook very clearly. You tell me this one. How to give? Mostly, importance to aldehydes only. So it's the first carbon, no? 1, 2, 3, 4. Double bond in between 2 and 3. So what? But. Okay. Double bond in between 2 and 3, no? You take the lowest. But 2 in. Aldehyde means I told you, it ends with what? Al. But 2 enal. But 2 enal. Understood? Okay. Just this is all you know that. Likewise, we have what? Ketones. Ketones. First study the formula. What is the formula? R C double bond O R dash. It's the formula. You know that. Okay. So a lower number is minimum. We have 3 carbon. Minimum 3 carbon. Okay. So instead of R, we put what? CH3, C double bond O, CH3. 3 carbon, no, you know that. What is that? propanol. Understood? Then one side ethyl, methyl group, another side I put ethyl group. Tell me, what is this? How many carbon? 4. 4 means what? Butanone. When you come to 5 carbon only, give the numbering. Okay, numbering start from only 5 carbon. Okay, suppose one side. Okay, now numbering, when you give the number from left to right, second carbon only having keto group, no? Understood? 1, 2, 3, 4, 5. So keto group is present in second carbon. So pentane, I told you, all the ketone ends with what? ONE. So pentane 2 one, cut or not? Pentane 2 one. Okay, understood, right? This is all you know. Now we are going to study about preparations, properties and all. Okay. You want means you just copy them, 1 or 2 examples, just copy them. You want means. I'm going to teach both aldehydes and ketones together, preparation properties. Then I'll teach the carboxylic gases separately. Okay. Okay. Aldehydes, ketones put separately. 1 or 2 examples, just copy them. First study the formula. What's the formula for aldehyde? RCHO. Formula for ketone is RC double bond O R dash. Okay. Next. Next one. Right. Okay. So many examples is given in a textbook. Okay. So go through all the structure and give the and find out the name for that. Okay. Okay. Now we're going to study about, just put the heading, preparations of aldehydes and ketones. Okay. Put the heading, preparations of aldehyde. Here this side, preparations of ketone. Okay. What's the formula? R CHO. What's the formula? R C double bond O R dash. Okay. Right. Now yes. You make it. You write in a separate page. This one write in left page. This one write in right page. Okay. So some preparations are we can able to compare. Okay. First one. Suppose first one. Oxidation of primary alcohol. Oxidation of primary alcohol means, primary alcohol means what? CH2OH, no? CH2OH is called what? Primary alcohol. Understood? We oxidize primary alcohol by, what's the reagent? PCC we studied already. What happened? It becomes, do you know or not? Any primary alcohol is oxidized to get what? Aldehyde. That or not? Then this is oxidized, we get what? Carboxylic acid. The general alcohol is oxidized to get aldehyde is oxidized to get carboxylic acid. Generally, this is general principle, Okay. So what here what? So what's the product? Primary alcohol is oxidized to become what? Aldehyde. This is aldehyde, no? This is primary alcohol, no? Understood? It is primary alcohol. Okay. So now this part becomes what? Okay. Our aim is to get only aldehyde, no? Understood? If you oxidize primary alcohol, we get aldehyde. If you oxidize, secondary alcohol, see the oxidation of secondary alcohol. Secondary alcohol means what's the formula? Secondary alcohol means what? Or CHOH. Cut off. If you have CHOH, it's called what? Secondary alcohol. Understood? This is a way to identify. This is called primary alcohol. This is called what? Secondary alcohol. So secondary alcohol means here you can take instead of R we put CH3. So CH3, CHOH, CH3. This I will studied already in that chapter, no? Alcohol chapter, no? Chromic oxide. Chromic oxide is an oxidation agent which converts secondary alcohol into what? It's oxidation agent, no? What happened? It becomes second alcohol is oxidized to get what? Ketone, no? CH3C double bond O, CH3. Understood? Primary alcohol is oxidized aldehyde. Second alcohol is oxidized ketone. It's a general one. Generally, you must know all this. Okay, right. This one method. Okay. Now directly I go to the important reactions. Rosenman reduction. What is Rosenman reduction? What is Rosenman reduction? That concept just keep in mind. It converts acyl halide into reduction. No, reduction means what? Addition of hydrogen. In place of catalyst is what? Palladium and just keep in mind. Palladium and barium sulfate means you must know it is a Rosenman reduction. Understood? What happened? What happened? Product will be what? R C double bond O H plus what? HCl. So aldehyde, aldehyde we get aldehyde. General. Instead of this, we can put any methyl group or benzene, any benzene, phenyl group. Okay. Now, tell me. CH3C double bond O, Cl, H. What happened? The same reagent. We get what? CH3, CHO plus what? HCl. Ethanol chloride becomes what? Ethanol chloride becomes what? Ethanol. Okay. Rosenman reduction, I must know it is acyl halide becomes aldehyde. This one you have to keep in mind. Put in box. This only we keep in mind. Okay. Acyl halides becomes it's called acyl halide. RC double bond O Cl means called what? Acyl halide. Okay. Acyl halide becomes aldehyde. Instead of this, we can put benzyl, no? CH5 also we can get benzaldehyde. Okay. What's the use of this? What's the role of this? It's a catalyst. It is called what? Catalytic poison. Catalytic poison. Okay. What is catalytic poison? If you keep as it is, it becomes all. If it becomes alcohol. If you want to stop the reaction at the stage of aldehyde, we have to use what? Catalytic poison. So the reaction will be stopped up to this. Otherwise, it becomes what? Alcohol. We want to get only aldehyde, no? So the role of BSF for nothing but what? Catalytic poison. It stops the reaction at the stage of aldehyde. Just note down. It stops the reaction at the stage of aldehyde. It's called Rosenman reduction. Just write. Why you are not writing? You separate left hand side fully or write aldehydes, right hand side ketones. That's all. Okay. Finished? Here also the same acyl halides. Here also I am taking same acyl halides, but here this acyl halides undergo reduction. Yeah. But here same acyl halides I am taking here CH3 C double bond O Cl 1. We should write in. We should take 2 times. Okay. To that, dimethyl cadmium on compound is added. Dimethyl cadmium. Understood? Dimethyl cadmium. Okay. So what happened? This will be removed. Cut or not? CdCl2. Cadmium chloride will be removed. Okay. Minus CdCl2. The product will be, we have 2 CH3 now. 1 CH3 goes here, another CH3 goes here. So we get what? 2 times propanone. Understood? Right. How they will ask question means, they'll ask like this. Question, they'll ask like this. CH3 COCl. Okay. Arrow mark cadmium chloride. That's the question. Okay. So you must know, you should take 2 times this one. Okay. It's there in your textbook, is there. In text question is there. Sir, cadmium, sorry, dimethyl, no? CD, right, C3 twice, right. Dimethyl cadmium. So cadmium chloride will be removed. Okay, right. Question also write in right hand side. Any space means right. Okay, right. You study like this. Okay, so it will be easy, I think. Understood? First method, oxidation of primary alcohol. This is called what? Oxidation of secondary alcohol. Second method, Rosenberg reduction. This is also Rosenberg reduction. Okay, but it's in the textbook is not given. But here Rosenberg reduction, we are taking what? Basic compound is called acyl halide. The same acyl halides we are taking here. Okay. The compare and study, easy one. Okay. Next, right. Okay, third method, you know that. Third method, Stephen's reaction. All the naming reactions study thoroughly. Stephen's reduction, this also we can say reduction. Here, just remember, CN becomes CHO. This is a concept. Okay, tin chloride in place of HCl. That's all. This only keep in mind. CN. Nitrile becomes what? This is called what? Nitrile, no? Nitrile becomes what? Aldehyde. Okay. So they will give question mark. So here, suppose for example, CH3, CN. Okay. So here, what happened? This is CH3, CN means nothing but what? 2 carbon, no. 2 carbon is what? Ethane. Ethane nitrile. It's called ethane nitrile. Then this undergo reduction in process of reducing agent. Okay. So what happened here? HH, no? Cut or not? HH. Then this HCl is going to add here. Now it becomes, so all the reactions studied. CH3, CH double bond, NH dot HCl. CH double bond NH means called imine. Just write. Imine means it's a intermediate formed during Stephen's reaction. Okay, what's the intermediate formed? They will ask. Imine. Then again, what? If it is hydrolysis, what happened? It is hydrolysis OH2, cut or not? This side what? CH3CHO. That side what? Ammonium chloride, correct or not? Plus what? Ammonium chloride, NH4Cl. Correct? Questions how they'll ask means the questions will be like this. Okay. Simply CH3CN. Okay, tin chloride. Tin mean I remember like this. Yes, yes, no. Stephens. Tin chloride in place of HCl. So what's the product? So last product, I told you, no, CN becomes what? Aldehyde. That's all. Simple. If you anything, okay, see, before that any group is present, don't worry about that. Okay, CN becomes CHO. That's the role of this reducing agent. Okay, all the reducing agent just keep in mind. What is intermediate, that also study. Then same thing here, right hand side. Here also I am taking, we are going to get ketone only from nitrile. Same ketones here. Here nitrile means there also we are taking nitrile. Only compare and study. Okay. I am taking this compound, CH3. But this is undergo reduction, no. But here we are adding Grignard reagent. What is the Grignard reagent? CH3 MgBr. Okay. You know that? Plus minus. Minus plus. Just remember. That's all. You just add. It comes here, no? MgBr. So the product will be what? CH3C down CH3. Single bond, no? Sorry, not single bond, double bond. One bond will be reduced, isn't it? NMgBr. Again, whenever if you add Grignard reagents followed by hydrolysis, you studied. Compulsory, you should add some water molecule. Then only what? OH2. So what? This side what? This side, our aim is to get only ketone, no? Ketone. Understood? Then you write bond. CH3C double bond O. CH3 plus what? Mg is at valency 2, no? One side NH2, another side Br. Right fast. These kind of questions only they will give. Okay, complete the following. Okay. Sometimes again it goes on. Sometimes they'll ask to find out the reagent. What reagents if you add? Okay, reactant product they will give. Sometimes everything they will give. Very simple. If they want to set the paper very simply means everything they'll give. What's the name of the reaction? Okay. So study fully. Okay. Right. Next one. Then one more thing here. Tin chloride, no. Or sometimes we can use what? Tell me, what is it? Dibol. Do you remember dibol? Dibol means diisobutyl aluminum hydride. Dibol. That's also important. Dibol. Diisobutyl aluminum hydride. Same. What it's doing, it converts CN becomes what? CHO. The same function of this also. Okay, suppose for example, they'll ask like this. Before that, whatever it may be, don't worry about that. Okay, they'll give dibol. Dibol. Diisobutyl aluminum hydride. What's the product? CN becomes? Okay. Okay. I given clearly. CN becomes CHO. This becomes CHO. Understood? Right. Before that, CH3, CH, double bond, CH, CH2. Understood? Right fast. Studied all the name reactions. Once again, recall all this. You make a list. Okay, so at 10 chloride, it becomes CN, becomes CHO. Okay, then only it will be easy to study. Okay. Okay, finished. So both are, both the compounds are, both the aldehydes and ketones are obtained from nitrile compounds, nitrile. Okay. This one undergo reduction, but this one reacts with Grignard reagents. That's the difference. Okay. Next. Next one is what? Another name reaction study, no? ETOD reaction. Do you know that? ETOD reaction. ETOD. You heard about this one? ETOD. Very standard question. ETOD. What is ETOD means? It converts, just first you just memorize alkyl benzene, no? Alkyl benzene into what? Aromatic aldehyde. This only study first of all. Okay. By adding what? Chromyl chloride in place of CS2. This only keep in mind. Highly enough. Okay. Alkyl benzene into what? Or aromatic hydrocarbon sometimes. Okay. Alkyl benzene, why I am saying alkyl benzene means because on benzene ring we put some alkyl group should be there. Okay. Then this also acts as an oxidizing agent. Okay. You just remember, if you put this one, we have intermediate is also present. Okay. Don't worry about the intermediate. So you just remember, CS3 becomes what? What? Aldehyde. That's all. Okay. Any CS3 is oxidizing agent. Okay. We are getting in between. We have some intermediate will be formed. So CS3 becomes CHO. That's called ETOD reaction. Not only that, sometimes this reagent we can put, or sometimes we can put any acetic anhydride. Okay, acetic anhydride also you can use same for okay. In process of CrO3, just right. This also okay. Instead of chromate chloride CS2, or we can use acetic anhydride chromic oxide. Anything we can put. One question is given in a textbook. Suppose they will give you the question like this. CS3, okay, CS3, paranitro toluene. Is it toluene? No, correct or not? Toluene. Chromyl chloride, Cl, CS2. What's the product? What's the product? If you see this, what is the use of this? It converts. CS3 becomes what? CHO, that's all. This one, no changes here. Okay, product, tell me. CS3 becomes CHO. Okay, you study like that, then it will be easy. ETOD, you must know, it's a chromyl chloride and CS2, it's a solvent, it's an oxidizing agent. Okay, it converts the alkyl group into aldehyde. That's all. Okay. Okay, right. Here, this side. Wow. This side also, we are going to get, I am taking, here I think, Friedel-Crafts reaction, Friedel-Crafts, acylation. What is acylation? Acyl group should be added, no? As acylation. Friedel-Crafts reaction is always we must have one. See, both are same. This also, aromatic hydrocarbon. This also what? Aromatic hydrocarbon. Okay. Okay. Just compare. Acylation means what? Study, ETOD reaction. It's not ETOD. Rosenberg reaction. CS3C double bond O. What is this? Two carbon, no. Ethane. Ethanol chloride. Any Friedel-Crafts reaction compulsory who is there? Anhydrous aluminum chloride acts as a Lewis acid catalyst. You know that. Okay? Right. What's the product? Simple. Very good. That's all. Acetophenone. Understood? Product will be, that product is what? COCH3, acetophenone. Okay. From simply we can say E-TOT and free radicals reaction from aromatic hydrocarbon we can get, that's all. Benzylation means instead of CH3 pot we put CH5. Benzylation, this is called acylation. No? Benzylation, instead of CH3 put CH5, that's all. Benzylation. Okay. So benzylation, here we get what? Here we get acetophenone. No. If you do benzyl chloride, we get benzophenone. We get benzophenone. Okay, you do it later. CH5, C double bond O, Cl. We are getting what? Benzophenone. That's right. Benzophenone. Okay. These are fully named reaction. Study thoroughly. Okay. Toluene, no? Okay, right. One more reaction is here. What? Gatterman-Goch reaction, no? This also convert aromatic hydrocarbon into aldehyde. Simple. You take benzene, you add carbon monoxide in place of HCl or any anhydrous aluminum chloride also you can use. What happened? The CO only acts as a reactant. The CO comes here. We have to replace nitrogen? No. So it becomes what? CO becomes what? CHO. CO becomes CHO. Understood? Okay, that's all. Simply benzene becomes benzaldehyde. It's a Gatterman-Goch reaction. Toluene becomes, benzaldehyde, E-TOT reaction. Benzene becomes acetophenone or benzene becomes benzophenone, acylation or benzylation. Okay. These are the methods to prepare. Okay. Understood? Finished all this? All the name reaction? Okay. Study thoroughly. That's all. Preparation only write separately. After that, together you can write. Chemical properties of, we put common on heading. Chemical properties of aldehydes and ketones. Put on heading common. Chemical properties of aldehydes and ketones. Okay. Simple. Here, important 4 or 5 reactions are very important. That one study thoroughly based upon the last some question. So understand the concept. Okay. So I'm going to start the important reaction. You know that you studied already. Start from aldol condensation. What is aldol condensation? What is the condition for aldol condensation? What's the condition? What is the condition? Common should have. Common means aldehydes are ketones. Okay, should have what? Or simply you can write aldehyde or ketone should have what? Write fast. Alpha hydrogen. Okay. Okay. Can undergo aldol condensation. Okay. Aldol condensation in presence of what? In presence of dilute NaOH. See, if you see dilute NaOH or sometimes barium hydroxide also they put barium hydroxide. Okay. If you see this one and this one, you must know it is what? Aldol condensation. Are you following? Okay. They will give on compounds. So these compounds undergo aldol condensation or not. So what's the condition? You have to find out whether it is alpha hydrogen or not. Okay. If you have alpha hydrogen, this will undergo. Now tell me, examples. This having alpha hydrogen. What is alpha hydrogen actually? The hydrogen which is nearer to the function group, no? Actually, all aldehydes or ketones should have, if you want to say very correctly means, should have alpha carbon contains alpha hydrogen. You write like that. Alpha carbon contains. That's the correct one. Alpha carbon contains alpha hydrogen. Simply I put alpha hydrogen means some rule will not, some compounds we have some doubt will be there. Okay. First of all, find out alpha carbon. See, what is alpha carbon? Hello. What is alpha carbon? The carbon which is nearer to the function group. Is there any carbon nearer to the function? Is it a function group? Is there any carbon nearer to the function group? No carbon. No carbon, no. Function group, no carbon. So it will not undergo. CH3, CHO. This carbon is called what? Alpha carbon. Correct? This hydrogen is called what? Alpha hydrogen. Understood? Okay. The carbon which is nearer to the functional group is called alpha carbon, alpha hydrogen. So these compounds can undergo Hologen condensation. Understood? CH3, CH2, CHO. Having, no? This is what? Alpha carbon. Sir, alpha carbon. This is called what? Alpha hydrogen. So it undergo. Understood? Now tell me this one. C6H5CHO. Having alpha hydrogen or not? I am saying not. No alpha hydrogen. If you see like this, having alpha hydrogen, you same compounds you see in different way. Understood? If you see like this, no, this is a function group, no? The function group. This is what? Alpha carbon, but no alpha hydrogen. So this will not undergo. Okay? Cut or not? Okay. Okay, right. Just copy them, this one. Be quick. Copy them. Trimethyl acetaldehyde. This is called acetaldehyde, no? Common name is called acetaldehyde. All the compounds you just memorize. The first two compounds, common name. Yeah, this is methanol. This is called what? Ethanol. Okay. So sometimes you just memorize the common name also. This is called formaldehyde. This is called acetaldehyde. Okay. Suppose here I replace all the three hydrogen atom by methyl group. So CH3, okay, CHO. Is it undergo aldol condensation? Is it undergo aldol condensation? I am asking. Is a functional group? It's alpha carbon, but hydrogen? No hydrogen. No alpha hydrogen. No. Understood? No alpha hydrogen. So this will not undergo. Just right. Trimethyl acetaldehyde will not undergo aldol condensation because no alpha hydrogen. Okay. This only can undergo, no? This one can undergo. But cancer reaction, one more reaction we are going to study, that will be quite opposite. Do not having alpha hydrogen. If I put into, no, this all will come under what? This all will come under which reaction? Cancer reaction. Understood? Are you following? Okay. Right. Next one. The condition, remember, whenever if you see simply they will ask question like this. If you work hard, okay, before examination, if you work hard, the question will be very simple. Otherwise, you have to do work hard during examination, isn't it? You have to struggle more during examination. Before that, you have to struggle more. Question will be like this. Is it undergo aldehyde condensation? Alpha hydrogen, no. Another word, dilute NaOH. These two conditions just keep in mind. Okay. So this will undergo aldehyde condensation. Okay. Right. Can I rub this? Okay, see, now the question will be like this. What's the answer for this means what? Outright. Condensation means two molecules should be condensed, no? Two molecules, no? These two molecules should be condensed. So one molecule I am writing like this. See, very simple. You follow my way. One molecule we can write C double bond O. Another molecule we should write, this is alpha hydrogen, no? H plus CH2 CHO minus. That's all. Alpha, it's alpha, we have to split. This carbon component always is a polar character. C plus O minus. That's all. Now, dilute NaOH, what's the product? What's the product? H plus comes here, no? CH goes here, no? Understood? Now, tell me. You just add together. Product will be CH3, CH down, OH, CH2, CHO. Correct or not? This only having what? Aldehyde group as well as alcohol group. Then only I am saying what? Aldol. This is having aldehyde group and aldol. Are you following? Understood? It's called aldol. Okay. Sometimes they will give the question like this. Dilute NaOH, again heat. Two operations we should do. First operation, dilute NaOH. Second operation, we should do heat also. Heat means we should, what happened? This will be removed. Now minus H2O. Product will be what? CH3, CH. We are removing the H2O between these two carbon, no? Then only you have to put double bond in between them. Okay? Correct or not? Okay? Name, what's the name? I told you at 9:45. Now, but-2-enal. But-2-enal. Correct or not? Okay? Just copy them. Be quick. One common, if you know, means others you can able to write. One common, always you should write C double bond O. Another common, we should split them. H plus CH2, CHO minus. Carbanion. So what's the answer for this? Option A, option B. What is the answer? But-2-enal. Understood? The question will be like this. Just note down. Finished? Okay? Right. Next one is, crossed aldol. Crossed aldol. Crossed aldol means we should take two different compounds. This is both are ethanol, no? Correct or not? Both are ethanol. It's called, we can say, what we can say, if you want to say very correctly means simple aldol condensation. Cross means what? You should take different compounds. Okay? What's the condition? Should have what? Should have what? Alpha hydrogen, yeah. But they are saying, sometimes they are saying, at least one common should have alpha hydrogen. It's enough, they are saying. Suppose, what is this undergo or not? Benzene will undergo or not? Not undergo, no? Because also have alpha hydrogen. But they are saying, they are giving some, offer. Okay? When you take two common, at least one common should have alpha hydrogen. It's enough, they are saying. Okay? See, this one not having alpha hydrogen, no? Not having alpha hydrogen, you should write first. Having alpha hydrogen, you should write next. So, suppose I am taking this common. H plus CH2, CHO, cut or not? If we put dilute NaOH, okay, these are not having alpha hydrogen, but having alpha hydrogen. Okay, so, right now, Now it will, you know that. Now, product C6H5CH, understood? It comes, no? It goes here, you know, understood? OH, CH2, CHO, understood? Anyhow, we are getting all aldol, correct or not? Aldol. Okay? Huh? C square, where you put C square? You make a bond. One bond will be formed, plus and minus, no? One bond will be formed between them. C, single bond, CH2. Okay, bond only will come. Okay. Okay. Pranita? Okay. You try yourself. Okay. Ethanol and propanol, you try yourself. Later. Release some space. Okay, that's all. Again, here also heated, no? I told you, no, heated. It means here this also what? H2 will be removed. Okay, so product will be, again, if you heat means what happened? Product will be what? C6H5CH, double bond, understood? CHCHO. Okay, right. Chinnamaldehyde. Commercial name is called Chinnamaldehyde. Okay. Or we can say 1, 2, 3. 3-phenyl prop 2-enol. Prop. Correct or not? 3-phenyl prop. 3 carbon. Prop 2-enol. Okay? Right fast. Understand? Right. This one, do it yourself. Here sometimes both are having alpha, you know. Sometimes this one we should write first, this one next. Or sometimes this one first, this one next. Okay. Or sometimes this together in 2 times. This together in 2 times. Then only we are getting how many product? Just remember 4 products. Just remember. Cross dollar condensation, we are getting different kind of product. Okay. Are you following? Okay. 4 products only, just you write, then you do it later after that. Okay. Cross means we should take 2 different. Okay, right. Very important aldol condensation. They want to ask simply means which compounds undergo aldol condensation. Very simple. Okay, these are all they already asked in 2017-16. Okay, but I think you will be getting somewhat new questions. Okay, the coming year. Okay, right. Following. Next one is what? Here ketone also you can say. Ketone also I told you, no, this also undergoes suppose ketone also having alpha hydrogen or not? Alpha hydrogen is there, no? It's a functional group. It's a alpha hydrogen. Okay. So if you want to say very correctly means it's called ketol condensation. Ketol. Okay, but generally they are saying aldol condensation in your textbook. Plus another ketone. H plus CH2 C double bond O CH3. Correct or not? Okay. Here also dilute NaOH. If you see dilute NaOH means called aldol. Another one I am going to teach. Con NaOH, concentrated. That's called Candice 0. Just remember. Okay. Right. Plus, minus. You write yourself. Be quick. Propanol. Both are propanol, no? Write fast. Keep on practicing all the equation. Okay, right. Understood? Okay. You got the product? Written the product? What's the product? What's the product? CH3, C, CH3, you know that. H plus comes here, no? CH2 minus goes here. Now C, OH, CH2, C, no, not ketol, no? You know, keto group is present, alcohol is present. That's why we can say, generally we can say ketol. Understood? Again, if you want to heat means what happen? This will be removed, no? Okay? So the product will be CH3, C, CH3, double bond, no? Double bond, CH, C, double bond O, CH3. Okay? Right. Right, fast. Two conditions they will ask, the same question they will ask, simply they will ask, question will be like this, they won't give two times, you must know, condensation means you should write two times, understood? CH3C double bond O, dilute NaOH, understood? Heated, question mark, understood? So this is a product, in the product, you know, option they will give the name only they will give in the option, okay? What's the name? Give the number from here, no? 1, 2, 3, 4, 5. Pent, no? Correct or not? Pent. Double bond in between? 3. 3 in. 2 one. Here 4 having methyl, no? So 4 methyl, pent 3 in, 2 one. Correct or not? Okay? Right. You just practice one equation, highly enough. Okay, understand the concept. Next, the question will be like this. Note the question also of the last. Okay. If you have come across same, I told you know, if you come across same questions in many times, immediately you know the answer. Okay, you need not work out. Okay, finished? Right. Right. Next one is another one, just opposite to the top. Aldol is what? Can is zero reaction. Very simple. Just write conditions in write one, or others is called what? Disproportionation reaction. What is called disproportionation reaction? What is disproportionation reaction? One is oxidized, other is reduced, and other is write fast. Other is reduced. This is called what? Disproportionation reaction. Okay. Then what's the condition? What is the conditions? Do not have alpha hydrogen. Simply write. Okay. This is one condition. What's the another condition? What? Use con NaOH. Okay. Better. That is CC. Remember. I remember like this. CC. Okay. We have a lot of work, no? Okay. We have a lot of work in our day-to-day life. Okay. So, but you remember like this. Stephen's reaction, tin chloride, yes. Con, CC. Okay, right. Then, do not means what? Who will undergo? Only the formaldehyde and benzaldehyde can undergo cancer reaction. What? Concentrated NaOH. Understood? Okay. I told you, one is oxidized, one is reduced. One is oxidized means this will be oxidized, this will be reduced. Understood? This is the basic principle I told you in the beginning at 10 o'clock. What's the basic principle? Tell me. Any alcohol is oxidized? Aldehyde, just write CHO. You must know. Any aldehyde is oxidized to get carboxylic acid. This is a basic principle. Okay? Or COOH. Understood? It's called what? Carboxylic acid. Understood? Right. So, I'm telling this is oxidized. This is what? Reduced. Oxidized means what? CHO becomes what? Carboxylic acid. Understood? Carboxylic acid means, just listen, SCOO. Understood? I told you, aldehyde becomes what? Acids. Understood? But here NaOH is there, then only we are getting the product always HCONA. Plus other is reduced. Reduced means what? Reduced means what? We have to add hydrogen. You put like this, simple. What is this? CH3OH. I told you, no. If you go this way, oxidation. If you go this way, what? Reduction. Understood? Okay, no. Reduction. That also right. Okay. The basic things, if you know, means the simple one. You need not memorize all this. Okay. Now, what's the product? Tell me. CH3OH. That's all. That's right. Write fast. Understood? Any doubt? Then you write yourself. This equation. This is the first equation. Then another equation. You write yourself. If I suppose the question will be like this. The question will be like this. Concentrated NaOH. What happened? They won't give 2 times. Sometimes they won't give 2 times. You must know. What's the product? One is oxidized, one is reduced. So what? CHO becomes COONA. Okay, correct or not? Plus CH5, CH2OH. That's right. Write fast. Write fast. Listening, learning, writing, going on simultaneously. Then only we can able to complete the portions. Write fast. Understood? Are you following? Sometimes cross not. This is simple, no? 2 times I'm taking same compound. Same compound, simple. If I take different compounds, you write reverse. Okay. Mostly homework. You put it homework. Right. HCHO, CH5, CHO. What? Right. Concentrated NaOH. Correct or not? Mostly smaller one can be oxidized. Smaller one. Yeah, smaller one compounds will be easily oxidized. Okay. This will be oxidized. This will be reduced. This only note down. Then after you can know how to write. Write first. Are you following? Aldol means having alpha hydrogen. Canazole means not having alpha hydrogen. Simple. Okay. Within one word I finished. But for explaining, I am giving more examples, then you can able to understand, isn't it? So having alpha hydrogen, not having alpha hydrogen, that's all. Simply keep in mind. Okay. That is dilute NaOH. This is constant NaOH. Okay. If this is called crossed aldol. Smaller one can be oxidized. So HCONA, CH2OH. Here CH2OH, no, that product. Okay, right. Another one. Write fast. Another one. Third one. Alloform reaction. All reaction very important. First 4 very, very important. Alloform reaction. Alloform means here also we have condition. We can prepare chloroform, iodoform. Then it is called alloform reaction generally. What is the condition means? What is the condition? What is the condition here? First condition is common should have what? CH3C double bond O. It's very important. Then common should have CH3CHOH. It's a condition. Any commons having this kind of group. What is this? Simply you can say methyl ketone. Can you say like this? Methyl ketone. Any commons having methyl ketone. Any commons having methyl carbinol. It's called carbinol. Carbon plus OH, methyl carbinol. So carbinol. Okay. This is a condition. Okay. Right. Write fast. Methyl carbinol or methyl ketone. Okay. Right. Finished? This one finished? This one finished? This one. Okay, right. Then write alpha reaction, write the condition first of all. Methyl ketone or methyl carbonyl, okay, can undergo, you write like this, can undergo alpha reaction, can undergo alpha reaction in presence of Cl2NaOH. If you put chlorine, NaOH means we can get what? Chloroform. Or if you use iodine in place of NaOH means what? We get iodoform. Okay. That's all. Now you have to say compounds having. What is this? You tell me which compounds undergo. So you make it as a, don't write CHO, you write C double bond O, then only you can able to understand. Okay. Tell me. C double bond O, I put it here. CH5, C double bond O, CH3. Understood? CH5, C double bond O, CH5. Understood? CH3, CH, OH, CH2, 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 CH3. Understood? CH3, C double bond O. Okay. Now you first write all the compounds you put into Arctic. Understood? First write all the compounds, you put tick mark. What's the condition? CH3, C double bond O. Having no? That group is present or not? Methyl ketone. This is a condition, no? So, understood? This will undergo alpha reaction. This one, CH3CO is there or not? Methyl ketone. Correct or not? This will undergo. Here, this is called ethyl ketone. Methyl ketone only simple. This will not undergo. Correct or not? Here, phenyl ketone. This will not undergo. This is what? You see this side. What is this? Methyl ketone, no? What is the name also you must memorize? Okay, I have written only the structure. What is this? Benzaldehyde, acetophenone, benzophenone. Understood? So this will undergo. Okay, right. Write fast. Okay, you take break for 5 minutes, I'll come. Okay? You write all the compounds, you put tick mark. Okay? Which one undergo, which will not undergo. Okay? Right. I'll come within 5 minutes. See the next one. We finished all this. This one. What about this one? This will not. This will not undergo. This will. No. CH. Oh, methyl carbinol. Understood? This will undergo. Pentan. They'll ask like this. Which compounds undergo? So pentan 2-ol can undergo. This is pentan 2-ol can undergo. This is pentan 3-ol will not undergo. Understood? Are you following? Okay. Pentan 2-1 will undergo, pentan 3-1 will not undergo. Understood? Just keep in mind this one. That's all. Then equations, based upon equations, how to write means here. So, see, listen, here I given so many compounds now, alcohol, ketone, aldehyde, but only one aldehyde can undergo. Which aldehyde? That's a very important. The only one aldehyde can undergo alpha is first compound. See the first compound. Ethanol, no? CH3C. The only one aldehyde can undergo alpha reaction is what? Ethanol, the only one aldehyde. Okay, so keep in mind the only one aldehyde. Okay, other aldehyde will not undergo. Okay, other aldehyde having what? Ethyl ketone, propyl ketone, like that. Okay, right. Conditions keep in mind. Then equations. I'm taking the same compound. Say R. Tell me this is CH3, C double bond O H. First, I2 is added, chloroform, for iodoform preparation, I2 and NaOH. This is a reagent, no? What's the reagent? Ri2. Yeah. First, iodine is added, so what happened? Replace the 3 hydrogen atom by 3 iodine. So, CI3, simply write, don't, okay, CHO. Then, what's the other reagent? Sodium hydroxide. So, it will be like this. What is this? CHI3. CHI3 is the what is this? Plus remaining SCOONA. This is called what? What is this? Iodoform. Understood, right? You write C3C double bond O CH3. Tell me. Replace alpha hydrogen. It's alpha hydrogen. No? You can replace anyone, this one or this one. Anyone? Tell me. See, don't worry about the balance equation. So just replace this 3 hydrogen atom by 3 iodine. Okay, product will be C double bond O, cut or not? CH3. Again, tell me. What's the second reagent? NaOH. So H from here. What is this? CHI3 plus. You start from here. CH3COONA. Correct? CH3COONA. Write fast. Then you try yourself later. Okay. Do it. Finished? Finished or not? The only one aldehyde can undergo alpha reaction is only ethanol. That's it. Okay, remember, not other aldehyde. Understood? First one over. Okay. Then fourth one is, test for aldehyde. What is test for aldehyde? How will you test aldehyde? Alpha reaction, it's considered as a test for ketone, we can say. Okay, if you it's not a yellow precipitate. Yellow precipitate is obtained. Okay, so it's a ketone compound, so it's a test for ketone. The ketone reacts with iodine in presence of NaOH to form yellow precipitate. Understood? Right. Next one is test for aldehyde. What are the tests? We have tolerance test and filling solution test. No, filling reagent test. Filling test. Filling. Okay. What is tolerance reagent? Ammoniacal silver nitrate is called what? Tolerance reagent, Clear? If you put aldehyde in this reagent, aldehyde reduces tolerance reagent to what? Metallic silver, Okay. Silver is, shining appearance due to the formation of, silver. That's why it's called what? We can say silver mirror test. Silver mirror test. Okay, right. Aldehyde reduces tolerance reagent, at the same time this will be oxidized. Okay. The equation knowledge is there. The equation just go through your textbook. What is filling solution? Filling A, filling B. What is filling A? Filling A is what? Aqueous copper sulfate solution. No? This is called what? Alkaline. It's called aqueous. Alkaline sodium potassium tartrate. Correct or not? Sodium potassium tartrate. This only we can say it's called rose chili salt. Rose chili salt. Okay. These are the reagents. If you put this reagent, aldehyde, actually it's a blue in color. It becomes red in color. Okay. So statement will be like this: aldehyde reduces, filling solution to red cuprous oxide. Red cuprous oxide. Here one exception case is there. What is the exception case? Aldehyde, I am saying aldehyde, no. But here one exception case is there. That's called, which aldehyde does not undergo? Benzaldehyde, just right. Except benzaldehyde, just right. Benzaldehyde. Because of bulky group, that's the reason they are saying. Only aliphatic compounds can undergo. Aromatic compounds will not undergo, especially the benzaldehyde. Huh? Reduces filling solution to red cuprous oxide. Red cuprous oxide. Okay, red cuprous oxide. See, this is a tolerance test, fillings and alloform. The three tests only, just keep in mind. Based upon this, they'll ask some question. What question means? Chemical test to differentiate. To differentiate, that's the question. You put the heading like that. Okay. So suppose, for example, simple one, CH3CHO. CH3, what is this? CH3CO, CH3. What is this actually? Actually, it's called what? Ethanol. This is called what? Propanone. They'll ask the question like this. Write the chemical test to distinguish ethanol and propanone. This is just three tests only, keep in mind. What are the tests? tolerance test, filling solution test, what? Alloform. Okay, this. Okay, which test to use to differentiate? This also CH3C double bond O, no? This also having CH3C double bond O. So alloform, both can undergo alloform, no? Correct or not? Both can undergo alloform. So alloform we should not do. Tolerance or fillings. Okay. So this will undergo tolerance test. This will not. Understood? Right like that. Be quick. Second one. Benzaldehyde. Likewise, you prepare yourself. Benzaldehyde or acetophenone. These three tests only just keep in mind. Okay. How will you differentiate these two compounds? Who is having C double bond O? C double bond O CH3. This one having CH5 C double bond O CH3. This is what? CH5 C double bond O. You know. This having what? Having what? CH3. So this will undergo alloform. This will This will undergo alloform. Correct or not? This will not undergo. Then one more. Fillings. This also will not undergo. This also will not undergo. So only one test. Are you following? Okay. So benzaldehyde, but tolerance. Tolerance. We can say. Tolerance we can say. Tolerance. This will undergo, but this will not undergo. Ketone will not undergo. This one we can say first one. This one. Tolerance it will undergo. Okay. This will not undergo. Correct or not? Okay. Right. These three only just keep in mind. That's all. Finished? Written all this? One more thing you try. Third one. Ethanol propanol. Do fast. Ethanol propanol. Which one undergo? Which test to differentiate? Alloform. Methyl ketone, here methyl ketone, here ethyl ketone. So this will undergo what? This will undergo alloform, this will not. That's all. Okay, right fast. These three only keep in mind. So this type of question they ask me, so you can able to answer. Okay. Any doubt? Okay. This three tests only you must know. Then only you can able to differentiate. Okay, the two compounds. Okay. Ethanol, propanol, very important. Okay, you must know. You expand you write the structure for this. Then only you can find out whether it's having C double bond O, CH3 C double bond O or not. This is CH3 C double bond O. It's got CH3 CH2 C double bond O, ethyl ketone. So this will not undergo alloform. This will undergo alloform. Both can undergo tolerance, no? Both can undergo tolerance, but we should not say like that. Chemical test to differentiate. Understood? Right. Other reactions, this is the most important reaction, four reactions. Okay. Other reactions, only mild reactions only. Clemenson, Wolff-Kishner, both are looking same. Fifth one is, Clemenson reduction. What? Next one is what? Wolff-Kishner. Okay. Both are converting C double bond O into what? CH2. That's all. Keep in mind. Carbonyl becomes what? Hydrocarbon. Okay. This also convert C double bond O into what? CH2, like that. Okay. So Clemmensen means, just remember, very important one, zinc amalgam con HCl. If you see this reagent, you must know it's a Clemmensen. Okay. Here hydrazine, mostly we can use hydrazine in place of glycol, KOH, these are all reagents. Okay, keep in mind. See, simply I'll give one example. See, simple one example I am taking, CS3. So in case of this given means you make them to write C double bond O. It's easy. It supply what? 4H, that right, 4H. This also supply what? 4H. Okay, right. What happened? It's a reducing agent, 4H is supplied, same reagents. What happened? You know that? 2H, cut or not? We are getting only hydrocarbon, that's all. CH3? CH3, cut or not? CH3, hydrocarbon only we are getting. Okay. So ethanol becomes ethane, cut or not? Ethanol becomes ethane. Understood? Now you write one more compounds, you write propanone becomes write fast. Split like that. Propanone becomes propane, cut or not? Okay. So 4H only, just keep in mind. Okay. Propanone becomes CH3, CH2, CH3. Understood? Right. Same. The reagent only differ. Otherwise everything same. The method of adding, method of getting product, everything same. The reagent only differ. Okay. What is this? They won't give 4H. 4H. They will give only what? Con HCl and zinc amalgam. They will give this only. So you must know this is a Clemmensen reduction. 4H should be added. Okay. What's the product? Tell me. The name of the product? Name of the product? CH5? CH3. Toluene, correct or not? Toluene, no? CH5? CH3. Understood? Toluene. Okay. Just now we studied, this is called, benzaldehyde to toluene. Benzaldehyde to toluene is a Clemmensen reduction. Toluene to benzaldehyde is a, at 10:15 we studied. Toluene to benzaldehyde. It starts from E. ETAD reaction. Okay. Just keep in mind. Okay. It may be Clemmensen or Wolff-Kishner, both are same. Okay. So ETAD is what? Just toluene to benzaldehyde. Clemmensen is what? Just write. Okay. It's called benzaldehyde to toluene. Okay. Very important. Right. Same thing. Okay. Reagent only differ, the same process. Okay. Some of the last very important reagents they'll give ethanol to ethane. They'll ask to find out the reagent. Okay, when aldehyde or ketone, okay, any carbonyl compounds becomes hydrocarbon, we have to undergo reduction. Okay, it may be zinc amalgam con HCl, or it may be hydrazine in place of glycol KOH. Okay, keep in mind. Okay, next one. Written all this. You write yourself. Okay, same compound. You take any ketone, aldehyde. Okay, the same process. Then mostly I covered. Then one more reaction is that the other simple reaction you study yourself. Seventh one, nucleophilic addition reaction. Nucleophilic, just right, nucleophilic addition reaction. Simply I'm taking this one, CH3C double bond to H. Addition means, nucleophile group is added. Okay. Not substitution reaction, nucleophilic addition reaction. So what? HC and hydrogen cyanide, no? This always you should know. C plus O minus. That's all. You just add together. What happened? Very important. This one CH3, CH, CN kata down OH. Then very important. Whenever if you see CN cyanide, it undergoes hydrolysis. They will simply put like this. What's the common they loss? CN becomes COOH group. Just remember, most of the place it comes here. Whenever cyanide undergo hydrolysis, so we get what? The product will be what? CH3C, COOH, then what? OH. Simple. Hydrolysis means you should add 2 times water molecule. Okay, 2 times water molecule. This will be removed. That is, NH3 will be removed. Remaining what? COOH. Understood? COOH. Understood? CN becomes COOH group. Okay. Understood? Right. Write this one. What is this? It's having what? What is this actually? It is present in milk. It is present in milk. What? Lactic acid. Okay. This will undergo. It's optically active, correct or not? Optically active. Because of what? Chiral carbon. Understood? Okay, right. They are giving this question like this. Okay. That is, CH3, CHO, SCN, followed by first operation SCN, second operation H2O, like that. The product, what is the product they'll ask? Question may be like this. Okay. Answer is what? Lactic acid. Understood? Sometimes instead of CH3, they use C6H5 also. Okay, same method. That's called mandelic acid. Mandelic acid, but it's not given in textbook. Okay. Okay. Next one, electrophilic substitution reaction. Next one. Electrophilic knowledge, I told you, what is electrophilic means here. What kind of director? That only you keep in mind. Electrophilic substitution reaction. Understood? Both electrophilic means always you should take what? Only you should take aromatic compounds. Benzaldehyde as well as what? It may be acetophenone or benzophenone. Both are what? Meta-directing group. This only keep in mind. Meta-directing group. Okay, yes. Deactivating group. It's called meta-directing group. Okay. Now, what's the product? Suppose here, are you following? The aldehydes, benzaldehyde, acetophenone only meta-directing. All the groups are what? We consider as a ortho and para-directing. First chapter, chlorobenzene we studied. Correct or not? Second chapter, alcohol, phenol we studied. Phenol and anisole. Both are aromatic compounds, both are ortho para-directing group. Third chapter, benzoic acid also. We have benzoic acid, no? Okay. All the aromatic aldehyde, aromatic ketone, aromatic acids, all is considered as what? Meta-directing. This, okay, meta-directing group. Okay. So simply they'll ask, they will check students know or not what kind of directing group. So simply, CHO, it's process called what? Nitration. What's the product? They will put like this. Concentrated nitric acid and concentrated sulfuric acid. What's the product? Nitration. What happened? Meta-directing group. So we get the product? Meta-nitro. That's all simple. Meta-nitro Benz aldehyde, that's all. Okay. Now you must know the what kind of directing group. If you know this, you can able to manage. Okay. You tell me. This also what? Metachloro acetophenone. Correct or not? Right fast. What kind of director? If you know means you can able to understand the concept. Okay, right? Okay. So I'll go through. Then some ammonia derivatives one is there. That sometimes they'll ask in complete the following. Okay. Next. Okay. Here. Next one is, reacts with ammonia derivatives. Reacts with ammonia derivatives. You just write. It's a very simple one. Ammonia means, NH3, Ammonia derivatives means what? Replace one hydrogen atom by, I put OH group. This is called what? Hydroxylamine. Correct or not? Hydroxylamine. Okay. Then replace one hydrogen atom by, I put one more NH2 group. What is this? It is called what? Hydrazine. Replacing here one hydrogen atom by phenyl group. Okay. So what? Phenyl hydrazine. Then replacing one hydrogen atom by amide group. Amide na NH2 C double bond. Are you following? Replacing one hydrogen atom by amide group. CO NH2 group is called amide group. Remaining as it is. This one is called somewhat different one. Semicarbazide. Okay. This one is very important. Okay. Simple. Reactions are very simple. See, whenever it reacts with, you should write like this. All C double bond of faces to that molecule. Then only we can eliminate what? Water molecule. Understood? So all the reactions are going like this. We can eliminate here what? H2 will be removed. Here what? This H2 will be removed. So when you write reverse direction. Okay. This one is very, very important. Okay. CH3. You write. They will not give like this. They will give CH3 CHO. But you faces to C double bond of faces to that molecule. Tell me. Here also CH2, here also H2, here also H2, no? Okay. So it's very important. This should be retained in the product side. We should not touch this one. Always should take hydrogen from here. Okay. Amide, just only note down. Amide should be retained in the product. So this will not react. Always you should take what? This hydrogen we should not take. Which hydrogen we should take? Are you following? Okay. The product will be, okay, they'll give like this because everyone taking this one. Okay, so that's the product they'll ask. They'll give, but not like this. Amide group should be, this group should be retained there in product side. Okay, product will be what? CH3 CH double bond NH C double bond O NH2 is called product. For a product will be semicarbazone. Always indents with ONE. Okay. Hydroxylamine, no. We get the product. Oxine. Hydrazine, no. Product will be hydrazone. Here, phenylhydrazine, no. Product will be what? Phenylhydrazone. Like that. Okay. The last one is very, very important. Okay. Go through. Okay. You write yourself simple one, giving. All these compounds are ammonia derivatives, okay? Because replacing one hydrogen atom by all these group. Then it is called what? Ammonia derivatives. Understood? What's the product? Which hydrogen we should take? This hydrogen or that hydrogen? This hydrogen, no? Okay, understood. So this will be removed. What molecule will be removed? Get or not? So you should write like this. Okay. Double bond N NH C double bond O NH2. Write like this. Understood? Finished? Understood? Don't study only one time. If you study only one time, it becomes 0 time studies. Okay? They both are same. One time is equal to 0. Many times. Okay? Every day you should see organic reactions. Every day. Okay? Thursday, Friday, Saturday, all the days you should see the name reaction. Okay? You be ready. You know, each and every chapter we have some name reaction will be there. No? So name reaction every day you must see. Then only you can easy to find out. It will consume the time. If you do any sums in physical chemistry, it will take some time to find out the answer, isn't it? But it will consume the time. Immediately we can find out what is A, what is B. We can easily find out. So, okay. So then only if you work hard before that, it will be easy. So all the name reactions keep in mind. Okay. Right. So go through all these. These are the important properties about aldehydes and ketones. Okay. Then I am going to start the acids, carboxylic acid. Next, the first 4 properties important. First I told aldol, canizero, alloform, test for aldehyde. Okay. Oh, that's all. Then Clemmensen is also study. Okay. Then electrophilic substitution reaction is also important. Okay. Then carboxylic acid, ready. What's the formula? We have monocarboxylic acid formula is what? RCOH. Dicarboxylic acid formula is what? CH2N COOH COOH. Understood? N may be, N start from 1, 2, 3, it goes on. Okay. Then as usual, this is all very simple. We studied in lower classes. H, COOH, CH3, COOH, CH3, CH2, COOH. It ends with what? How it ends with? Oic acid. 1 carbon, no? So what? Methanoic acid. These are all very simple. Methanoic acid. I told you, first 2 compounds you study both. Common name as well as IP's name. What is this? First acid, no? Formic acid. This is called what? Acetic acid. Understood? This is present in redant. Then I am writing in red color. It's a strings of redant. I heard about this one. Okay. When ant bites us, what happened? Immediately we are getting pain. The pain due to it is giving what? It is producing methanoic acid. We are getting some pain. So Formic acid, it is present in strings of redundant. Okay, redundant. Okay, understood. It is present in vinegar, no? Vinegar. Okay, right. This first two compounds, you should know both the name. Okay. Then it goes on. That propanoic acid, butanoic acid. Okay, it goes on. You go through. Okay. Then come to dicarboxylic acid. This is called, if you want to see very correctly, it's called what? Monocarboxylic acid. This is called what? Dicarboxylic acid. Dicarboxylic acid. Understood? Right. That's CH2N, COH, COH. N starts from 0. Okay. Okay. Right. Tell me, N is equal to 0. N is equal to 0, no? This will not come, no? This will not come, no? We have only this one. COH, this COH. N is equal to 1, 0 means this is a compound. N is equal to 1 means what? CH2, COH, it goes on like this. Understood? N is equal to 2, okay, CH2, CH2, COH, okay, COH, it goes on, okay. So, it's called first acid, no? Both the name also, just remember. IPS name, it's called, common name, it's called what? IPS name. Ethane, 2 carbon, no? Usually, oic acid, but dicarboxylic acid is how to use, which one you use? Ethane, 2 carbon, no? Ethane dioic acid. Understood? Ethane dioic acid. Understood? This is called what? Malonic acid. Malonic. Just right. This is now they want to ask. Mostly if they want to meet, they will ask this only. Okay. It's called succinic acid. Okay. This is called what? Propane. 3 carbon, no? Propane dioic acid. This is called what? Butane dioic acid. Right, like that. It goes on. Okay. Following. Finished all this. Now we are going to see only the preparation, few method of properties. Okay. Then you put the heading preparations, that is preparations of carboxylic acid. Okay, simple one, already studied. What is that? Studied already. If you use primary alcohol, what happens? If you put one powerful oxygen agent, directly convert primary alcohol into what? Carboxylic acid, no? Understood? Are you following? If you put one powerful oxidizing agent, suppose for example I am taking ethanol, If you put one powerful oxidizing agent is nothing but, potassium dichromate, potassium permanganate, or Jones reagent, a somewhat different reagent is given, nothing but CrO3 dot con H2SO4. Okay, just write. It's a powerful oxidizing agent. What happened? It becomes what? This part becomes what? Carboxylic acid. Understood? Okay. Product will be what? CH3COH. Whatever it may be. Primary. What's the use of this? It converts primary alcohol into what? Carboxylic acid. That's right. This one you write. Okay. This one method. Another method, same thing we studied. Toluene 8 attraction study, just like here. KMNO4, KOH, alkaline KMNO4. Simply you can say KMNO4, KOH. It's very important, this one. See, whatever it may be, any alkyl group, KMNO4, see, here 1 CH3, listen, look at the board. It is going to get carboxylic acid. 2 carbon, yeah. It also will get carboxylic acid. This also 3 carbon, it will be carboxylic acid. Don't worry about the 3 carbon now. 3 times carboxylic acid. Only 1 COH will be there on the RMR. Okay, whatever it may be. Methyl benzene, ethyl benzene, propyl benzene. We are getting only benzoic acid. Understood? Okay. Before that, you studied, that one intermediate will be that cook. Just remember. Cook. Always students are saying like that. Cook. I don't know. Here, who is the intermediate product? Cook is the intermediate product. Cook nothing but one. Potassium salt of carboxylic acid. Okay. But here also you are getting cook. 3 cook will be getting. Okay. Don't worry about if you have 3 carbon means 3 times cook. Okay. This is a specialty of this reaction. Okay. Whatever it may be, the alkyl group becomes acids. That's the point. Okay. Wow. Always we are getting the product is what? Carboxylic acid. Okay. Right. These reagents keep in mind. Okay. What's the use of this? Each and every one you write like this. It will be easy. What's the purpose for adding this one? It converts CH3 or CH3CH2 or CH3CH2CH2 becomes what? What? Carboxylic acid. Correct or not? Okay. The final product only they'll ask mostly. Okay. Simple one. Very familiar reaction, this one. KMNO4 KOH. Okay. Then another method from Grignard reagents. Third method. Okay. From Grignard, simple one. Grignard reagents. Third method is, from Grignard reagents. Grignard. What's the formula? RMGX. Understood? RMGX. Okay. If instead of R I put CH3, Mg, anything we can take. Okay. Plus carbon dioxide. How to write carbon dioxide? C double bond O. Kata? Okay, right. You know that? That is carbonyl group, I told you, plus minus. Minus plus. Okay, one side only is going to add. This one keep as it is. What happened? MgCl goes here, no? CH3 goes here. No product. This side will keep as it is. No changes. This side as it is. Double bond. Down. Who will come? CH3, no? CH3. Single bond O, Mg, Cl. I told you, whenever in case of lignite agents, you should add hydrolysis. Understood? Simply OH, H. What is it? This side? CS3? CS3 COOH. Carboxylic acid. CS3 COOH. Are you following? Simple. Okay. Plus subproduct. Don't worry about the subproduct. Okay, Mg, OH, Cl. Okay. They'll ask the question like this. I think CS3, MgCl, CO2, first operation CO2, second operation H2O. Find out the product. What is this? Now I change the question. What is this? What acids? First operation CO2, second operation H2O. What's the product? A is what? Which acids? I use aromatic, no? Benzoic acid. Correct or not? Okay. So A is what? Therefore A is what? Benzoic. Right like that. A is what? Benzoic acid. That's right. So third method. Okay. Then we have only 4 methods. One more method I'll give. Okay, right. Fourth method, hydrolysis. When you do hydrolysis, some compounds. Okay, practice is all C double bond O means C plus O minus always. So this will always minus. Okay, it's called electropositive character. Metals electropositive character is called. Okay, electron donating nature. Then I put minus. Okay. Now hydrolysis, say we can ester hydrolysis, acyl halides hydrolysis. Okay, so here hydrolysis of nitrate we get. B hydrolysis of ester we get acid. Okay, we get hydrolysis of acyl halide we get. See, nitrile means what? What is nitrile? Cyanide, no? Okay, suppose then CS3, I told hydrolysis in presence of acid medium. What happened? Whenever CN, I told whenever CN means you should use 2 times. 2 times, okay? Understood? Yeah. If they will not give 2 times, but they will give only 1 time. But you must remember, CN becomes what? COOH, correct or not? Okay. Now, ester. What is the formula for ester? R, COO, R dash. Understood? Product. Instead of R, CS3, COO, CS3, you add water in presence of acid medium. What happened? Here also here. Our aim is to get what? Acids, no? Understood? So CS3, CS3, COOH plus what? CS3, OH. So these are the method to get. Understood? Right. Okay. Acyl halide. Acyl halide means I given formula already. What's the formula? RC double bond O Cl. Where we studied Rosenman reduction. Correct or not? Acyl halide. RC. First memorize the formula. Okay. Simple. Instead of R, you put CS3, C double bond O, Cl. Hydrolysis means water is added in presence of acid medium. What happened? Correct or not? CH3, COOH, carboxylic acid we get, no, plus HCl. Okay. So all these compounds are hydrolysis, we get acids. Product will be, you know that, you write yourself. Here only sometimes they are using on pyridine. Pyridine is a catalyst. So not catalyst, it's a base. Then only we can eliminate what? HCl molecule. Are you following? Okay. Finished? Then I'll give some important chemical properties of carboxylic acid. Okay. First three methods important now. First three methods study thoroughly. Okay. First three methods, what are the methods? From primary alcohols oxidized by Jones reagent. Second one, alkaline KMnO4. Third one, reacts with carbon dioxide, Grignard reagents. The first three method is very important. Okay. Then properties, chemical properties. Very important. The first one, I start from easy one. Very important one also. What is this? HVC reaction. I heard about this one. Volhard-Zelensky reaction. Okay. What's the use of? What is this? It converts carboxylic acid. That concept you just keep in mind. HVC reaction, it converts carboxylic acid into alpha halo acid. That's all. This in presence of red phosphorus. Okay. Red phosphorus in presence of chlorine. H3O plus in the acid medium. Understood? Correct or not? This is the concept. All the reaction, what's happening in this reaction, you must know. Okay. Then you should get the product. In carboxylic acid, replace alpha hydrogen atom by halogen. That's all. Well, understood? Simple. Replace only alpha hydrogen. If you have alpha hydrogen in this compound, then we can undergo HVZ. If you have no alpha hydrogen, it will not undergo. So this will undergo or not? Having alpha hydrogen? Having no, this will undergo. This will undergo or not? No. This will undergo or not? No alpha hydrogen. This will not undergo. Correct or not? Okay. Simply the reason association question they will ask. Benzoic acid will not undergo HVZ reaction. Association what? Reason? Reason is what? Because of alpha, absence of alpha hydrogen. Okay, right. The equation, right, is having no. Then I am taking this reaction CH3, COH. No, simple. Red phosphorus, chlorine. Simple. Replace one hydrogen atom by halogen. What's the product? Replacement. Just CH2, Cl, COH. Understood? Following. Okay. Okay, you tell me this one. What's the product? What's the product? Don't replace here. Yeah, this is alpha hydrogen. Understood? Okay. CH3, CH, Cl, COH. Understood? Right. Okay, right. Benzoic acid will not. Right. Write and put into symbol. Okay. Finished? Okay. Okay. Next one. What's the next one? Kolb's electrolytic reaction. We already studied Kolb's reaction in second chapter. That is different. Kolb's reaction, no, that is phenol to salicylic acid. That's called phenol to salicylic. It's Kolb's reaction. Yeah, this is called, but this is a different one. Kolb's electrolytic reaction. Okay. Simple one. You take, don't take acids. Acid is a weak acid. No, this will not undergo electrolysis easily. Understood? Then only you take what? Are you following? Salt of this acid. Salt. Okay. If you take acetic acid, will not undergo electrolysis very easily. It's a weak acid. But if you take salt of this acid, it is somewhat, strong electrolyte. Okay. Then what happened? It undergo, listen carefully, very easy one. I'm going to compare the two equation. Now, what happened? It becomes what? CH3, CO plus what? Na plus. Where it goes? It goes to anode, no? It goes to what? Cathode. Are you following? Then, at anode, what's the reaction takes place? CH3CO minus. Okay. You write 2 times. Then only we get the product. What happened? CO2, CO2. 2 CO2. Kata. Minus, minus. 2 minus. Then there will be bond formed between CH3, CH3. What is this? One alkane is obtained. What is this? Product will be what? CH3. What is this? Ethane. Are you following? Okay. Questions will be like this. CH3, COO, what? Sorry. Na, electrolysis. What's the product? What is the product? What is A? First question. I'm going to write next question also later. Okay, this is A. B. Now tell me. Another one. CH2, COO, Na. Now tell me. What's the final product? Tell me. Final product. I want, it's a final product, no? Like this, you tell me. Final product name only I want. Butane, that's all, very good. Butane, correct or not? Butane, no? Okay, then tell me, it undergo electrolysis, what happened? What happened? CH3, CH2, COO, minus plus what? Na plus. So, I'm taking this only, don't worry about the other side. At anode, what happens? CH3, CH2, CO minus, you write 2 times, that's very important, write 2 times. Okay, then we can get the product. Otherwise, CO2 will be removed, minus will be removed, we are getting CH3, CH2. CH2 is not a product now. Okay, it's a radical. Okay, you write 2 times, CH3, CH2, CO minus. Understood? Right. I told you, no? What is this? 2 times CO2, 2 electron plus. There will be bond formed with this and this. Very important. Don't put the bond here and here. Bond will come. Okay. So it is a hydrocarbon, no? What's the product? CH3, CH2, CH2 are right in state, no problem. It's called what? N butane. Correct or not? Okay. You write in rough work this side. CH3CONA. Write the answer, write the question also, side by side. Electrolysis only. Okay, right. Write fast. This also right hand side. Okay. Now we know what's the answer here. We get A is what? Ethane. B is called butane. Get Propane will come or not? Propane. Propane not possible to come. Clear? Propane not possible to come. Only the even number. Finished? This also you, okay, write like this. Then I am going to compare this reaction with one more reaction, write fast. Decarboxylation reaction. Simple, very simple. This is, just understand the concept. Okay, alteration is split into ions. You write 2 times CO2, 2 electron will be, so there will be a bond formed between CH3, CH3, ethane. That's all. Just like this. Finished? Okay. Right. Next one. I'm going to another one. Third one. Decarboxylation. The decarboxylation and electrolytic reaction, just compare and study. Then it will be easy to understand. What is decarboxylation? Removal of what? Removal of carbon dioxide by using soda lime. Okay, just remember. Okay, D means what? Removal, no? Okay, removal of CO2 by using soda lime. What is soda lime? It's a mixture of calcium oxide. It's a mixture of sodium hydroxide and calcium oxide. The ratio 3:1 ratio. Understood? Right. Write fast. Same compounds I am taking. Sodium acetate I am taking. What is sodium acetate? CH3CONA. Correct? Understood? Previous case we had taken, no? We took the same compound, no? Okay. Soda lime. What is soda lime? It's a mixture of sodium hydroxide and calcium oxide. See that? See, compare and study. What is this? Same compound, no? The same compound undergo electrolysis, we get ethane. Are you following? The same compounds undergo, we are going to get methane. That's the difference. Understood? So what? This will not involve, this one is involved. What happened? Tell me. This will be removed, no? Kata. H goes here. What happened? CH3 becomes CH4. Correct or not? Plus sodium. This will not involve. It's a flexing agent. It will not involve. This one involve. Okay. Are you following? Same. Just compare. Just compare and study. Then only I am writing here. CH3CONA. Tell me. Soda lime. Correct? Same compounds undergo electrolysis. We get ethane. Same compounds undergo decarboxylation, we get methane. That's the difference. Are you following? Okay. Compare and study. Okay. You write yourself. You know that CH5, CONA. Tell me. Soda lime. What's the product? What's cytocarbon? What's cytocarbon? C6H5. Better? We get benzene. That's all. Very good. Understood? We get what? C6H6 plus what? Sodium carbonate. Understood? Right. Okay. Right. Fast. Then esterification and all you prepared. You know, we already studied that alcohol chapter. Okay, acid plus alcohol to get ester. You study yourself. Then one more important is called okay. Finished? Right. Only few reactions I will complete. Finished? Just compare and study these 2 reactions again and chemical properties, which one is most important, I will give in the first 1, 2, 3. The weightage is going on, decreases. But not like that, but you study everything. Okay. Which one is most important, I will give in the first. Okay. Fourth one, reacts with ammonia. Very important this one. For complete the following, this reaction very, very useful. See, you know that. See, you take ethanoic acid plus ammonia, listen. What is this? You just add. What happened? CH3, COO, NH4, no, ammonium acetate. Again, if heat means what happened? We get amide. CH3, CO, NH2, we get amide. So, simply you can say ethanoic acid to what? Ethanamide. Correct or not? How they'll ask means, listen, question will be how they'll ask means, see, CH3, COOH, what? Ammonia, first operation, second operation, heat to get A, again Br2NaOH. If you study all this name reaction means, it will be, you can easily understand. NaOH. What is B? Tell me. What is A? Tell me first of all. Everything on the board. Answer on the board. What is A? Where? What am I? Ammonia, first operation ammonia, second operation heating. What is A? A is what? Correct or not? Ethanamide, no. What is this reagent? A is what? Ethanamide. Correct or not? A is what? CH3, C double bond O, NH2. What is this reagent? You study now Hoffman bromide reaction. Amine chapter. What's the purpose for this? What's the role of this? To remove what? To remove CO. Correct or not? What happened? Now product will be what? Methanamine. Correct or not? Understood? So therefore, B is what? Methanamine. CH3, NH2. Are you following? Understood? Right. This type of comma they'll ask. Yep. Can go on. Okay. Suppose here, if you add chloroform, KOH, alkyl KOH, what happened? What is C? You studied means you can have, no, it's a name reaction. This also a name reaction, this also a name reaction. Tell me. What is this? Amine. Test for amine. Chloroform. What is the test for amine? Carbylamine reaction, no? This is amine, no? Primary amine, no? So what? We get CH3. C is what? CH3, NC, methyl isocyanide. Understood? It's called C. So write like that. Okay. Understood? Amines, it's amines, no? So amines, chloroform, is the test for amine. Okay, carbylamine reaction. So we get the product C is what? CH3NC. Right. Likewise, you study all this, ethanoic acid to ethanamide, benzoic acid to benzamide, phthalic acid to phthalimide. Okay. So many reactions are there. It's a molar carboxylic acid I have given. So if you want means one more reactions, you just write. Phthalic acid means what? Phthalic acid. Have you written all this? Can I rub this? Last one. Last reaction. Okay, right. Then phthalic acid, you're right, the same reaction, you know, phthalic acid means what? COH. Here in this case you should add 2 times no ammonia. Correct? 2 times ammonia. So what? COO NH4 COO NH4. Now if you heat means what happen? This will remove no? Correct? Okay. Oh, NH. What's the product? CO NH2 CO thalamide. You know. This called not thalamide, thalamide. Okay, thalamide Jaisinga. Once again. What happened? Again heat means what happened? This will be eliminated. On NH3 will be removed. Just keep in mind. Okay? This is called thalamide. Gabriel thalamide we studied or not? C double bond O, C double bond O, NH. It's called thalamide. Just right, thalamide. Okay, that's called thalamide. Okay, right. All the reactions go through. Electrophilic. I told you electrophilic. What kind of reaction? What kind of director? Benzoic acid is a what kind of director? Ortho? Not ortho. Meta. All the aromatic aldehyde, aromatic ketone, aromatic acids. All are what? Meta directing group. Just keep in mind. So they'll give the question like this. Yeah. Last one. Just write. Concentrated HNO3 and concentrated H2SO4. What's the answer? Meta nitro. They'll give the question like this. What kind of directed phenol means you get the answer. Understood? The meta nitro. Correct or not? Meta nitro benzoic acid. Okay, right. Likewise, chlorination means metachloro. Okay. Okay, that's all. These are the important things in aldehydes, ketones, carboxylic acid. Okay. So properties I'll give on notes I'll give. If you follow me, you can understand all this. Okay. So all the lessons I'll give separately. Properties. Okay. Okay. Don't study one times, many times study, then only it will be easy to understand. Reagents, keep in mind. Understood? Right. Okay, ma. We will see in the next class. Okay? See you.